Okay. This is our 23rd lesson. We have ended our studies on a fortiori principle, and we'll have some more materials on that. Perhaps a little bit later we may hit it a time or two again, some little points here or there, but we're pretty well done all we want to do on that subject. What we're looking at now is what is called the induction process. Induction is a process in logic. There's inductive and deductive logic. And so we're going to look at induction and how it works. Inductive reasoning is used by people in their everyday lives. So we use it in our daily lives. It's very helpful in understanding the scriptures, and I believe it's a good way to approach a study of the scriptures, to use induction whenever we're studying the scriptures. We're going to introduce inductive reasoning and make some applications of induction at this time in this lesson. Let's define it with a lexicon or a dictionary. An induction, or to induce, according to Webster's Merriam-Webster Collegiate Dictionary, 10th edition, is determined by induction. Well, that doesn't help you very much. And then he says specifically, they say to infer from particulars. What you do in induction, you take 2 or 3 pieces of information and you draw the conclusion for a universal premise from. And so induction, you have to be careful with it. We need to understand how we work with it here, how we're going to use it. You arrive at a universal conclusion from particular premises. Not like deductive reasoning. Deductive, we start with a universal premise and we draw a particular conclusion from it. Or we may draw a universal conclusion from it. Because of the nature of induction, it does not usually give us a conclusion that's certain. So we're not necessarily certain of it. All right, so when we look at it, we're going to look at it. When we approach the scriptures, we're going to draw a little bit different conclusion. So it's important that we look at it carefully. In the American society, science is thought by many to be the only way that we know anything. That is called scientism. And everything you know is by science. This is almost the way of thinking of most people. And scientific knowledge is tentative because it's always based upon inductive process. Then it's not certain. Now, some scientific knowledge is not exactly proven, but it's so probable, the probability is so high that we live by it. You live by it when you fly in an airplane, Bradley's principle, lift on an airplane wing and so forth. But when we look at this, now we need to be understanding. So since scientific knowledge is tentative, many people say, well, that's the only way we know anything, therefore we can't know anything with certainty. All of our knowledge is tentative. This is more widespread than you might think in the thinking of people. That is, all truth is tentative is being taught by some in the Lord's church even. They picked it up in college. They picked this up in the colleges. When I took some philosophy of education courses in universities, I attended 3 different universities where I took courses, and all 3 of those universities taught that knowledge is tentative. They taught John Dewey's view, and he taught that the only way you know anything is by science. This is what's been taught in our school systems now. This is the thinking of most of your teachers that come out of teacher colleges. So they've corrupted our whole educational system in the United States. Barker, in his logic book, Elements of Logic, says non-deductive inference in which the conclusion, that's the inductive reasoning, expresses an empirical conjecture. that goes beyond what the premises say. Now, empirical has to do with your senses. Seeing, hearing, smelling, tasting, touching, those five senses. So that's what they're talking about here. Goes beyond what the premises say. That is, the conclusion implies something not implied by the premises. It can be confirmed or refuted on the basis of evidence drawn from sense experience. And of course, science is based upon empirical knowledge. Deductive reasoning is employed in science. It's the basis of the scientific method. Science is knowledge obtained by the empirical means, by your sense, your one or more of your five senses. We use inductive reasoning in our daily lives. To illustrate this, let me say this. An auto mechanic hears a knocking sound in an engine, and he discovers a certain defect in the engine. He hears the same knocking sound in a number of other engines, and he always finds the same defect in them also. So he's tried this, and he's heard this sound in maybe 10 or 15 different engines. He draws the conclusion that when he hears this again, that this is almost certainly the problem with the engine that he's experienced before. When you're troubleshooting like a car or something like that, based upon the experience, you've done it over and over and you've seen the same symptoms. So you draw the conclusion that that's probably the problem. And usually you're right. Physicians do the same thing. They practice medicine. They get more information from other scientific studies, and they use the scientific studies of other scientists. But they still project it based upon what they've seen. He does not even ever hear the sound without it having this defect. He concludes the engine probably has this defect when he hears the same knocking sound. Does that make sense? Right.
Yes, it does.
So an inductive proof is one that moves either A, from a group of assertions about some events and things or situations of a certain class, to an assertion about all such events or situations, like the mechanic. He's heard half a dozen or maybe 10 or 15 times the same knocking sound in the engine. He concludes that it's probably some particular problem with the engine, and he therefore draws that conclusion. When he hears that same knocking sound, and he says all situations where I hear that sound are almost certainly that same problem, and that's how we operate. And we do this, and you don't have to be a scientist to use, pardon me, to use inductive reasoning. We do it all the time. And so what we do is illustration with a mechanic. Same thing would happen with other fields of endeavor. A woman baking a cake or something, she may see something happen, and it may accomplish something in her process or something. I don't have a good illustration for it, but I will tell you that if the barometer goes up or down, it takes less or more time to cook the cake. Okay. Because the lower barometer takes longer, because it boils, the water boils at a lower temperature, so it doesn't cook it as fast. It takes longer to cook it at a higher altitude. Now, they have recipes for different altitudes for different things. James, you're up near a mile high in your altitude. Your wife probably has to cook things a little longer than she would if she's down like in Oklahoma City or somewhere like that. Would that be true?
That's true. And we noticed a big difference when we moved here from Nebraska.
Yeah. So that's what you run into. You run into things like that and you see it happening. And if the barometer goes up or down, high pressure, low pressure, things will cook faster with the high pressure than they will with the low pressure area. And so anyhow, that's a person that really is into the know will realize that, and they'll watch their baking. If the barometer goes up, things are going to cook quicker, and the biscuits will burn, more likely to burn. Okay, but let's look at the second one. Or B, it goes from assertions about miscellaneous things and events to an assertion that explains them in a relatively simple way. So it might take the miscellaneous information and explain what's going on in that way. And it's just like the cooking of the baking of the biscuits. When the barometer goes up or down, you may burn the biscuits, or they may not be cooked fully. If it's a low pressure area, it takes a little longer to bake. Suppose, here's an example of inductive reasoning. Suppose that disease X, just some disease, call it disease X, is found in 1,000 people, and 50 of those people are tested for a certain bacteria, let's call it bacteria A, in their bloodstream, and all 50 have the bacteria in their bloodstream. Suppose we have another 1,000 people who do not have the disease, and 50 of them are tested for the bacteria, and none of them have the bacteria in their blood. Now, we've got some pretty strong evidence here now. We're probably going to link this bacteria A with that disease. Does that make sense how that operates? Now, of course, from statistics, they may want to test more than 50 people, and they may want to test 2,000 or 3,000 out of maybe 50,000 people, or a bigger sample. And the probability gets higher and higher that the disease, bacteria A, is the cause of disease X. But if they don't find any of the people that don't have the disease that have the bacteria in their blood, none of them have it, then the following inductive argument could be made from some degree of confidence. But let me give you what we've done. I think all three of you in the logic class too. If we have an A-top proposition, that's what we're claiming here. We're claiming all people who have disease X have bacteria A. That's what we're claiming. And we're saying, okay, the information shows that to be the likely case. So if we assume that's true, then we come down here and we start looking at people with this disease, and we look for them. So we have an A-type proposition. All people with disease X have bacteria A. Then we come over here, we're looking to falsify that, and that's how science works. They're trying to falsify it with remember, an O-type proposition, and that would be some, meaning one or more persons with disease X don't have bacteria A. And if you find one that doesn't, then that falsifies that premise. See? And you might go back and double check them to make sure that your test was good, but that would falsify the premise that all people with disease X have bacteria A. So what you're doing is you're postulating or theorizing an A-type proposition, which you then negate with an O-type proposition. Are there any questions? That's what they're looking for in science. That's what they're trying to falsify the premise that all people with disease X have bacteria A. Any questions? That's how science works. All people with disease X are tested and found to have bacteria A in their blood. And then we look again and again. We're looking for somebody with disease X who doesn't have that bacteria. And we keep coming back with contradictory evidence that we say we're looking for contradictory evidence, and we don't find it. So what we're saying is there is no evidence that tells us that people can get disease X without bacteria A. We keep drawing that conclusion. Everybody has the bacteria that has the disease. So after a while, and testing many thousands of people, the mathematical probability becomes so low that we just say that bacteria A causes, or is a factor at least, in the disease X. Does that make sense? Any questions? You get into what's called probability, and that's the likelihood of this being, and you get into probability and statistics. And so that's where you get into that. You're trying to falsify it with an O-type proposition, just one or more instances where there's disease X without bacteria A. And since you don't find any contradictory evidence, you keep coming back, there's no contradictory evidence, you draw the conclusion probably disease X is linked to bacteria A. It's linked to it somehow. Now, the fact that the bacteria is there doesn't necessarily mean it's a causal factor. So that's a problem with some people's thinking. It might be that the disease allowed the bacteria to come in, and the bacteria didn't cause the disease. So you got to be aware of that. Might have been something else that came in. Might have been a parasite that had that bacteria, and the bacteria didn't cause the disease, but the parasite was causing it. Any questions there? We have to be very careful in our reasoning, okay, in science. Now, I understand we're not trying to deal with science here, but we have to deal as Christians with people making arguments from science that supposedly falsify the Bible. So we need to understand how they can reason wrongly in some of their scientific reasoning. In order to increase the probability of having a correct conclusion, that we would need to test more of the subjects. Among the 950 not tested in our group, or get a bigger group. Now, we don't just choose all the people that have red hair in the group, or all the people that are over 50 years old, or whatever. We need a random sample of the group for the statistics to be valid. And the bigger your sample is of your group, the higher the probability. But there gets to be a point at which, from a statistical standpoint, you don't have to test everybody. And so that's something we have to be aware of. If you're testing people to see how they're going to vote in an election, they made a mistake at one time in one election. They called people on the telephone to see. And this was back in the 40s, and what the people they were calling were the more wealthy people because they had phones. And a lot of the people that didn't have phones didn't get called, but they voted. So it wasn't a representative sample of the population as a whole. So you got to be careful with stuff like that. You'd not be certain that there was not another factor that caused both the bacteria to be present and disease to occur. Correlation does not prove causation. Keep that in mind. That's something very important to remember when you're dealing with this stuff. This is why scientists are always looking for evidence contradictory to their hypothesis. Remember, the hypothesis is an A-type proposition, and you're going to negate it with an O-type proposition. All right? Any questions? Suppose it was known that, here's another illustration, that all the specimens of a certain animal W, that exists in the whole world were in a certain zoo. Now, there are some animals that are near extinction, and there may be a situation like this. And we tested half of them, and we looked at half of them, and we saw that all one half of those animals, let's say we had 100 of the animals that was left in the world that we know about, and we looked at 50 of them, that'd be half of them. Then we looked at all of those, and they all had black fur. Suppose there was no contradictory evidence. We didn't look at any that had any color fur but black. We could make the following argument then. Here's the argument. All the specimens of animal W examined are known to have black fur. No specimens. We see we got an A-type proposition with the first bullet. Second bullet is looking at an O-type proposition. No specimens of animal W are known to have any other color fur. They don't have a non-black fur, see. So what we do is, and we don't have that, the conclusion is probably all specimens of animal W have black fur. That's our conclusion. Any questions? However, since we have all the animals in this zoo, if we look at all of them, if we examine all the animals, all the specimens of the animal, we could reason deductively from his examination. By examining all of them that all have black fur, then we can say, we looked at all the animals that exist that are that kind of animal, and now we conclude then that all of those animals have black fur. So if we choose animal animal number 15 out of the group, he has black fur. Animal number 16 out of the group has black fur because they all had black fur. So once we can look at all of them, then we cease to be reasoning inductively. We're not taking from a sample to the whole. We're going from the whole to the sample. We're reasoning deductively then, once we looked at all of them. The deductive argument would be the zoo contains all the specimens of animal W. Examination of all the specimens in the zoo demonstrates that they all have black fur. Conclusion, all specimens of animal W have black fur. Any question? So now we've used induction to draw a deductive, a certain conclusion. The conclusion is certain. The only problem we could have if someone painted the fur, dyed the fur before we got to them, okay? But if it was their genuine fur, we would have a conclusion that would be solid. And we cannot be certain if we don't have all the facts in the matter being considered. So the more facts we draw, the more facts we have, more information we have, the more certain our conclusion is. That's the reason that scientific knowledge is said to be tentative, because they don't normally have all the facts in the matter. Sometimes even the measurement techniques that they use in such things as physical science have errors in the measuring system. The measuring system can affect the system. Let me illustrate this. You have a small sample of water at a certain temperature and you put a thermometer down into it. What happens? Well, some of the heat from that water has to flow into the thermometer and heat it up, so it actually decreases the temperature of the liquid that you put the thermometer into. Does that make sense, everyone? So your measuring instrument can affect the system. What's happening in the system can affect it. And many measuring instruments, really basically all measuring systems do that to some extent. This is the reason we don't allow science to be the final judge in how we interpret the scriptures. Science should never trump, veto, or cancel or nullify a sound, reasonable interpretation of the scriptures. This is a major problem in hermeneutics. So we get careful. We cannot be certain if we do not consider all the facts in the matter being judged. We can be certain if we have both have all the facts and consider them being studied. And the claim that there's no absolute truth is made throughout the educational system of most of the Western world. It is something I've been trying to get the church to see it, and our brethren won't listen to me. It just scares me to death. They're being eat up with it now. And you hear this from people. True, can't be certain about anything now. Jesus endorsed inductive reasoning in Matthew 6, verses 2 and 3. Now, let's look at that passage, Matthew 16, 2 and 3. If you will, open your Bibles there. And I'll read verses 1 through 3. And the Pharisees and Sadducees came to him, trying him, asking him to show them a sign from heaven. But he answered and said, when it is evening, ye say it will be fair weather, for the heaven is red, and in the morning it will be foul weather today, for the heaven is red and lowering. You know how to discern the face of the heaven, but you cannot discern the signs of the time. The color of the sky is going to tell you about the barometric pressure and the humidity and the things that are in the sky. And Jesus is making a point here. I have a science book that actually explains these two verses of scripture. I think I have it in my notes somewhere in one of my apologetics materials. But I actually have the book. It's stored up. I need to get it out sometime, but I have it. I taught out of it one time. But this is the inductive process. You look at the sky, you know what's going to happen. And I don't remember they say red sky in the morning, so a sailor's warning or something like that. Red sky at night, evening, something. I've forgotten exactly how it goes, but there's a good little ditty that works too on this. One test of a prophet, however, let's look at our passages such as Deuteronomy 18:21 through 22 was that there was not to be any contradictory evidence against him. If you read it, Deuteronomy 18:21 and 22. So all the signs that he said must come to pass. So he has to be 100% accurate. If he misses one time, he's claiming I'm a prophet, so God will work the signs because he's of his prophet. And so it'll always work. The signs will always come to pass. But if it doesn't one time, that's an old type proposition that falsified his claim. That's what we have here in Deuteronomy 18. There are several key words in applying inductive reasoning to the scriptures, however, when we look at it. And they are why, when, what, who, where, and which, and how. And we look at the Bible and we answer these questions. Now, let's look at this some more. Let's go to Matthew 16, in that passage that I just read. But he answered and said to them, when it is evening, you say it shall be fair weather and the heaven is red, and in the morning it's foul weather today, for the heaven is red and lowering. You know how to discern the face of heaven, but you cannot discern the signs of the times. They had asked him a question, but he responded to them. They were discerning, making a distinction, the face of the heaven when they observed what occurred just prior to the changes of the weather. And they saw this again and again, the sky looked like this, and then the weather happened, and the weather changed. They should have been able to make the teachings of the scriptures, take them and discern by inductive reason that Jesus was the Messiah. That's the Lord's point. That's his point. You're able to look at the sky and tell what the weather's going to be, and you're accurate. And you should have used the same principles with me and determined that I was indeed who I claimed to be. Because they asked him to show him a sign from heaven. But he said, you've seen the signs up in heaven. You've seen me work the miracles. You've seen me teach Deuteronomy 13 and Deuteronomy 18, if we go back to those passages. Deuteronomy 18 and Deuteronomy 13. Those two passages of scripture, when I look at them, they give us two signs, two things that have to be true for a prophet. Number one, the signs that he says are going to happen must come to pass. Always. He can't fail. One time he fails, he flunked. But he flunks the test if he fails one time. Gets what I'm wrong. And what he teaches must totally be in harmony with the scriptures that they already possess, whatever scriptures they possess. Should have been able to make the teachings of the scriptures, take them and discern by inductive reasoning that Jesus was indeed the Messiah. He was fulfilling one prophecy after another. And one test of a prophet was there not to be any contradictory evidence against him, as we saw in Deuteronomy 18. And if thou shalt say in thy heart, how shall we know the word which Jehovah hath not spoken? How are we going to know that this is not truly a prophet? When a prophet speaketh in the name of Jehovah, the thing followed not, nor come to pass, that is the thing which Jehovah hath not spoken. The prophet has spoken it presumptuously, thou shalt not be afraid of him. Now, let me illustrate this. We ask, well, why didn't God just say, why didn't he just, when a false prophet prophesies something, why didn't God just see that it doesn't happen every time, anytime? Well, you could manipulate God if that were the case. If I was a false prophet and I wanted it to rain tomorrow, I could prophesy that it's not going to rain. And God, if he had to always falsify what I did, then I would make God my servant. He would have to make it right to falsify what I had claimed. But the fact is, I've got to be right every time. I might guess about something. I might guess that we're going to have a certain person to be elected president in 2024. Might guess something to that effect, but I would just be guessing because I have no way of knowing. But you say, I might be right. I might predict it, might be right. Well, so I mean, that doesn't prove I'm a prophet because I've got to be right every time and everything to prophesy. So don't be afraid of him if he ever misses it, if he's ever wrong. If it doesn't come to pass, if it doesn't follow, then God hasn't spoken it. He's not a prophet. He's presumptuous, and don't be afraid of him. You are to fear a true prophet because you feared the message that he gave to you because it was from God. Contradictory evidence proves that one is not infallibly guided. Just one time he fails, he's not a true prophet. Any questions? To be a true prophet, one must give signs and not have any contradictory evidence against his signs. His signs must always come about. Any contradictory evidence will falsify his claim to be a prophet. Illustrated by the square of opposition chart. What we have here, all of it, all SRP, all of his signs must come to pass. If they don't come to pass, if some of them don't come to pass, we have the all SRP A-type proposition is contradicted by an O-type, so S or not P. If just one, some means one or more. If just one time he fails, he said this is going to happen and it doesn't, he's automatically a false prophet. You know it for a fact. Are there questions?
I would make a comment. I believe the saying that you were looking for was red sky at night, sailors delight. Red sky in morning, sailors take warning.
Yeah, okay, I think that's it. Thank you.
You bet.
There I was in the Navy and couldn't remember that. Okay. All of his claims to work signs will occur for a true prophet. This is an A-type proposition, our square of opposition chart. The A-type proposition is falsified or contradicted by an O-type proposition. Just one time he fails, he's not a true prophet. So God, his prophets always got it right. The claim all signs occur is falsified, but some signs do not occur. All signs that the prophet says are going to happen occur, you falsify it by some, meaning at least one. Signs do not occur. Okay? Now back to our square of opposition. Let's look at some key words used in induction now. There are several key words in applying inductive reasoning to the scriptures. And of course, these are why, when, what, who, where, which, and how. And each of these words, Rudyard Kipling had a little saying with regard to that, but he called them his helpers, I think. Each of these words can be framed into a question which either may or may not be answered by the scriptures. So we frame them into a question and we try to get an answer to it from the scriptures. This is the inductive method of studying the scriptures. So we ask why, when, what, who, where, which, and how, and so forth. And that's what we want to do when we're studying the scriptures. All right? Inductive reasoning goes from a particular proposition to a universal proposition. And we're going to have another lesson or two on inductive reasoning. We're going to expand it more fully as we go through this. Now, if you're in the logic class, there's a whole chapter on reduction, and we're not going to go into that. I'm not going to keep it in sync with the logic class. We'll cover that later in the logic class. Induction, when we have all the facts in the matter, becomes deductive reasoning. If I know about all the facts in a matter, then we reason inductively from it. So here's the thing. If you assemble all the information in the Bible on a particular subject, and you know you got all the information on it, then you can reason deductively from it. You use induction to get all of the instances, like we did with the animals with the black fur. Jesus used inductive reasoning. The Jews were instructed to use inductive reasoning in the passage we just noted earlier. And when they tested whether or not one were a prophet of God, they were to use that. Deuteronomy 13, Deuteronomy 18. And Key words, of course, are why, when, what, who, where, which, and how. So those are simple words. We learned these back in the elementary school, or maybe late elementary school, but at least somewhere along that line. So this is how we're going to be approaching the scriptures. Are there questions?